Hello and welcome to our expert hands-on workshop on Reyrolle PC tools. My name is Chris Edwards and I'm happy to be your moderator for this webinar. Our expert today is my colleague and good friend Ozan Onat, who is a technical product promoter for Reyrolle and is based in our office in Hebburn near Newcastle in the UK. We will record this webinar and make the recording and the slides available to all registered participants. If you have any questions, please feel free to post them at any time during the presentation in the Q&A field. I'll then put your questions to Ozan at the end of his presentation so he can answer them live in the dedicated Q&A session. In addition, you can also use the chat field if you have anything other than questions you wish to contribute. Please be aware the chat is available in live mode only. Q&A questions will be answered via email if we run out of time during the live session. And just in case you are in full screen mode, press escape to see the Q&A and chat box. Ozan, I'm sure everyone is eagerly waiting and ready to learn more about Reyrolle PC tools, so I'll stop talking and hand over to you. Take it away.
Thank you very much, Chris, for your kind introduction. I'm sure everyone is waiting. Now, I am Özcan, and today we will see Reyrolle engineering tools briefly. First, we will start with a presentation, but don't worry, I will keep it short. And then we will switch to software itself. First, Reyrolle Evolution, and then Reyrolle Manager 2. So let's start. Reyrolle Engineering Software Suite is the configuration and management toolset for the whole Siemens Reyrolle protection service. There are three submodules called Reyrolle Evolution, Reyrolle Manager 1, and Reyrolle Manager 2. Reyrolle Evolution is the tool for easy configuration of almost all relays except for Reyrolle 5 relays. The configurable relay series are all 7SR1X, 7SR2X, 7SR45, 7SR46 series. And all legacy devices like 7SG series are also supported for backward support. Reyrolle Manager 1 is the enhanced configuration tool for 7SR1X and 7SR2X series with IEC 61850 support. Reyrolle Manager 2 is the exclusive tool for configuring Reyrolle 5 devices. And today we will see Reyrolle Evolution for an easy configuration of a 7SR10 device and Reyrolle Manager 2 with hands-on Reyrolle 5 relay configuration. Now, Reyrolle Engineering Tools Suite is easy to learn by yourself, thanks to its intuitive and straightforward user interface design. This keeps the training costs as minimum as possible. And also, it's free of charge. This means that you can download Reyrolle Engineering Tool Suite for free of charge from Siemens download area, which is called SIOS. And you can see the screenshots here in the slide. And you can install and start using directly out of the box. There are also relay template files and firmware files available to download in case of new firmware or template files released. All you need to do is to register for a user account in SIOS to download any content, and you can simply search for the word Reyrolle in SIOS. You will always find the latest version of the software package at the top. So you don't need to search for versions. You can directly scroll at the top level and click Reyrolle Manager, which you can see the version v02.21, which will include entire package, including Reyrolle Manager 2, Reyrolle Manager 1, and Reyrolle Evolution. Now let's start with Reyrolle Manager 2 to have a short, brief information. But before going any further, I just would like to emphasize that as a cybersecurity rule, the connection between the relay and PC is always encrypted. And the configuration package and firmware package are also signed. This means that a Reyrolle relay can only be uploaded by only Reyrolle engineering tool suite. Now, here are the basic features of Reyrolle Manager 2, just for a brief information. Now, function configuration is kept as simple as possible by intuitive user interface. You are just able to find your way while browsing the entire software. All the parameters are saved in a single file, which contains the entire settings and configurations. So in your Windows file structure, you will only see a single file for the configuration. Just like CFC feature with Protect relays, Reyrolle series have graphical user logic with drag and drop feature. For the frequently checked measurements, the user can assign the required meters as favorite meters. This provides a reduced effort on site. So you don't need to search for the necessary meters if you have already assigned the favorite meters. You just need to click, just press the button one time, and you can see the favorite meters at all time whenever you need on site. The users are able to add 5 user-defined screens as well. And also, the local time of the computer can be sent individually before the time server is set up on site. Now, this is a main introduction screenshot from the Reyrolle Manager 2 screen. Whenever you enter your relay, you will see all your settings and all your options here in a brief user interface. Now you see on the left-hand side your relays in your project, and you also see your IEC61850 substation, which contains the SCD file. On top, you will see the device information, the name, MLFB, and here the status means if you need to compile IEC61850 settings, you will see the warning here. If you don't need, it will say just no compile required. And you will also see the ID name of the relay you are currently working. There are 3 buttons here to make the life easier. Instead of going down here, you can directly get the summary of the device you are connected via USB. You can just send the entire configuration to your relay with just send button here. You are also able to get the configurations or the device data via these 2 buttons provided here. These are directly the shortcuts that you can find here in these other icons. Whenever you choose a relay from the left-hand side, you will see the necessary menus here: function configuration, user settings, and the others. And the screen, the blue screen on left-hand side, is the welcome splash screen when you run Reyrolle Manager 2. With this splash screen, you create a new project, you open an existing project, or you can export the project you were working on as a zip file. And here you can see the recent projects you worked on. So you don't need to click on the open project and search through your Windows structure. The latest recent projects will show up here. On general basis, all Reyrolle engineering tools are intuitive, and the layout lets you to find your way easily. Now you see the user logic interface here, which we call Reyrolle Express. And you know CFC feature in the protect relays. It is just the same logic here. You just drag and drop your necessary gates. You will just drag and drop all the information, indications, trip or pickup information, or any binary input or output tags from here to the working area, and you can connect just like CFC, and rest is saved. And on the left-hand side, you can see the display screen customization window. With this screen, you are able to create your single line diagrams up to 5 displays. So those will be just like sheets on your Reyrolle 5 relay display. When you get the device data from an online connected Reyrolle 5 device, you can access all waveform records, device event logs, fault logs, and other logs. You can just double click on them, which they will open in a pop-up window, and they will sort from the most recent one at top to the older ones to the lower. Now, a brief information on Redis evolution before going to the software itself. Redis evolution is used for all 7SR10, 7SR45, 46, and 7SR1 and 2 series. And also the legacy products like 7SG series are all supported. So you can configure, connect, get the device data, all the configurations, and all fault data from all legacy products as well. It is quite an easy to use tool, which is quite straightforward and has a simple user interface. So the main intention to use Redis evolution is the basic application of the relay. So if you don't need IC61850 configuration or any enhanced configurations, you can directly use Redis evolution to easily configure your Reyrolle device. In just a few minutes, actually, you can just set up your Reyrolle device and get ready to use. And also the serial communication protocols can be configured via Redis evolution, like IC103, Modbus RTU, DMP3. Of course, all the protection settings and control settings are configured via Redis evolution, just like expected. So you can just pull the fault information, waveform records from the device. You can do all your parameterization. You can configure the entire protection. You can get event information, and here says this disturbance records, which is actually waveform records. Redis evolution, I will repeat here again. Redis evolution is available under the package as Redis engineering tools, just like Redis Manager 2 and Redis Manager 1. And with the package you download from SIOS, all the templates are already available in the package, so you don't need to download them again. But of course, if there are new releases of templates or firmwares, you just need to use SIOS download area to get the new templates for your relay, and it is easily installed by an executable file. Redis evolution, as you see, is a text-based software and is quite straightforward. And actually, it has all the basic functions that you expect from a relay configuration software. As you see here, everything is summarized here in folder structure. And if you click on any folders, all the details are all listed on the right-hand side with all the options available here to click and choose. If you download any waveform record from a Reyrolle device, Display Evolution will open the waveform record readily for you, which are quite scalable. And of course, all the event logs and fault logs can be downloaded and viewed through Display Evolution as well. You can also simulate, just like you can trigger waveform records as well without any fault. So you see the red triangle with red thunder here. If you click on this icon while you are connected to a Reyrolle device, it will trigger waveform recording. So you can directly get a sample waveform record from your device without a fault occurs in real time. As you see, the navigation is quite easy and straightforward. There are folder structures here, and there are necessary shortcuts at the top by some icons. And all binary input, output, and LEDs are configured via a matrix. Or you can directly choose in another way, which I will show you in a few minutes with Display Evolution software with hands-on. And there are also tabs here, which you can navigate through if you need. So if you need to use binary input and output configurations, you can use text-based menu, or you can use the upper tabs here to access the input, output, and LED matrices. There are also some utilities available with all Redis engineering tools, which are curve editor, language editor, and communications editor. These are available for all Redis engineering tools as submodules. So to help you while you are configuring your protection system, you can use the curve editor to align all your tripping curves and timing here with a more visual way. And you can list all your settings here, so you can align all your thresholds in a visual way. And we also have a language editor available. This provides the user to customize their own language. So it is a screen with original settings and alternate settings, which enables the user to compare and contrast all the text in between the original and the user customized language. So what you can do with this language editor is simply you can create your own customized language set. You can keep it, you can download it to another relay, you can create an entire new language set, or you can just change the signal or indication names depending on your local usage. There is the communications editor, which is for setting up and configuring the serial communications like IC103, the MP3, and Modbus R2. All the information is already available inside this editor, so everything is mapped, everything is available, all the signals, indications, trip and pickup information, LED, binary input and output information is already mapped. Now, after this brief information, now we are at the end of our presentation. Thanks for listening. Now, let's switch to the software itself, which will be more interesting for you. Okay. Now, when you open Reyrolle Evolution, it starts just like this, with a blank window, with a splash screen in the middle, and everything you need is here available. Now, switching to full screen. Now, Reyrolle Evolution handles the devices individually. So it is not related to a project. You create the devices individually as a standalone device, you configure them and save them as a single file. So each relay is handled individually. So what you do is simply, as Reyrolle Evolution is quite straightforward and simple to use, you can directly use the shortcut here from New From Template icon, or you can use File menu to create a new file from template. You see the Connect button here, which is also available here. And this is to open an existing relay file which you have already configured before. All the other buttons are available depending on your connection status or the window you are working at the moment. So let's start with a relay now from template. When you click on the new template, it pulls all the template file information from the installation folder. You can see lots of devices here because all the MLFP files are individual with some variations, and you can see the firmwares available in your computer. If you have more than one firmware version for the same MLFP, you will see them both, or more than two. You will see them all. And the top one, no, not top one, the bottom one will be the newest one, depending on how you sort them from top. But of course, it is not easy to find at first what you are looking for. So if you just type in your first a few characters of your MLFP here, and you can go directly to the MLFP templates where it starts. Now we have a 7SR10 and 7SR5 here on my desk, and with Reyrolle Evolution, we will configure a 7SR10, which is 7SR10 532JA212EA0. Now let's type first a few MLFP characters here and click on Find. Now you can see at the bottom here, let's scroll down a bit, and we will find the closest MLFP number here to our real device. So it will be 2GA21 2EA0, and this is the only firmware file here available. So I will directly start with this. I just double clicked and the template file is available now. At this point, all the settings are already in default values. Now the rest will be our configuration depending on our system and protection parameters. Directly the settings tab comes and welcomes you. Of course, there are the other tabs here. Now check them. The system tab gives you the brief information the template file you are using, the software revision, and the firmware revision as well. You see the serial number here because I have already used this template file with an existing relay. But whenever you connect to a new device, this serial number will be updated. Or if you haven't connected to any device before, the template file will show you a blank serial number here. So I can show you a random example here, which I will be sure that I haven't used that device in my computer. Let's choose one of them. Here is the second file. The serial number, I already connected, so sorry for this example, wrong example, but normally it can be blank. Anyway, now let's go back to our original file now. Here you can add notes depending on your requirement to remind you later. Here is the basic config. This is a graphical selection screen to enable or disable your features. So we can directly enable and disable protection functions here and other features. So let's enable phase over current protection function now. Whenever I click on this, you can see that a new row appears here because I have enabled phase over current, and sub menus, sub features, or sub protection tabs appear here immediately. Of course, depending on your requirements, you will enable them as well. So let's say instantaneous overcurrent protection here. Let's have inverse time over protection here with first stage enabled, or we can use another one, and all sub stages will appear just down under the available protection functions again. Now the main settings screen. This screen is actually the main window that you will spend your time at most. The other tabs will be your other details. Now you see here the blue text because I have changed something here. If I change something, anything here, all the changes are indicated with a color change. Now starting the system config, you can set here the system frequency and settings dependencies here. So this is important. This comes enabled. What does it mean? If I disable it, all the configuration settings will show up, even if you have enabled or disabled them. It won't matter. Sometimes people would like to enter all the settings, even if they won't enable them while in the live substation. So you can just create your own template and save for later use with system dependencies disabled. So if I use disabled, it is possible to make mistake as well. So we always keep it enabled so that all settings here are bound depending on you enable or disable them. So these are the other settings while you use your relay, the general ones. But here is the important one. We have two passwords for configuration settings and control of the relay. You assign the password here, and it is saved. But here, when I click on it, you see only 4 stars, 4 asterisks here, but it shows another number. This long string is the code for control password. If you lose your password, you need to use this code to retrieve. But of course, if you have Redis evolution file available, you don't need to use this. But if you lose your Redis evolution file, and if you forget your control password, this string will show up in your device screen. And you can change the name of the relay, and you can assign a feeder or circuit identifier name here. So let's call it task 77105, and let's call it room now. So it is all set. If I click on save just now here to make a backup before going any further, it will show up your Windows structure, and you can call any name here, and you can choose any folder from your PC. It will save, but I'm not saving right now. I will continue. Now this is a motor protection device, 7SR105, so I'm supposed to enter all motor parameters here to introduce those parameters to the relay, so that while it switches on or off the motor, it uses those parameters. Of course, this is again for mistripping. You can here enter your CT and VT configurations. You can choose 1 or 5 directly here, and you can enter directly by typing your CT ratio primary. If you need to choose the CT ratio secondary as a special ratio, you can choose here it's more sensitivity, more precisely. And the earth current input is also configured individually here. You can choose, because you may have a different set of earth current transformers, therefore you will need to enter it separately. So the ratio can be different from the primary phase current transformers. So the settings for earth current transformer is entered from these 2 settings. Of course, you can change the phase rotation. Now here the function configuration. This is more or less the same as the config tab you see here. So you can change directly from this text-based window to enable or disable your protection features, or you can directly use the graphical window here. You have 2 choices, and it is real time. So if I disable here the phase over current protection, when I go back to settings, you see that it is disabled now. If I enable here, now you see the configuration tab, the phase over current is enabled again. And it goes back to last settings that I have already chose before. So even I disable or enable it, all my previous selections come again, so you don't lose your data. Now, the current-based protections are listed here. Because I chose only phase over current protection enabled here, it only shows phase over current protection. While the tree is open here, I can change it. Now, the function config window is selected, so I see the enabling or disabling options here. But you see the tree here. If I choose enable here, immediately under current function comes here available to enable you for the detailed settings. Now, if we go under the stages, Now these are all predefined and predefined protection functions with the default values. So you will just again there is enable or disable function here for each stage, and you can enter all your protection settings as required. Here you can choose your inverse time curve depending on your requirement, and so on. Now the supervision folder includes all the supervision functions that your device has. Now we have enabled circuit supervision function. If we enable, let's enable from here, to close coil supervision, let's say, it will come here again. You can enable the necessary stages and all the subsettings are available. So this time it is the delay time. Now under control and logic part, you will have your circuit breaker, or in this case, it is equivalent to motor start and stop. Again, as this is a motor protection relay, we are supposed to enter the necessary motor parameters like motor start delay, motor blocked delay. And here is the input configuration for binary inputs. When you open input matrix, this is the text-based selection screen. You see all the indications available here to assign or to map to binary input. You will just come here, click on this 3 dots, and a new window appears, and you will see all your binary inputs available here. If I choose binary input 3, now it is selected. Now we have virtual inputs here as well to use inside the user logic, or maybe to send as a communication signal. If I click on OK, the selected binary input appears here. If I choose more than one binary input, they will appear here as listed. The other way of mapping your binary input is input matrix. This is much more graphical selection screen. So you directly see all your indications and inputs in a matrix view, and you can directly choose whichever indication you would like to map to a binary input here. Let's say call this a general alarm. If I click once, you see that row is selected. If I click secondly, now the binary input is selected. Now I'm switching back to settings tab. Here you can configure binary inputs individually, each one of them, for the pickup delay and drop-off delay. So you can, of course, these are the default values, but in this range, from 0 to 14,000 seconds, you can choose here any delay time you need, if you need, of course. And you can also choose binary inputs depending on how you would like to use them for your local or remote control. Sometimes you may want to disable an input for remote or local usage because you don't need, or you would like to interlock. And you can also choose here the inputs you would like to invert. So normally, if an input, as you know, is de-energized, then it is 0. If it is energized, it is considered as 1. but you can invert the behavior here. If I choose 1 here, the binary input will be inverted. So it will be 1 if it is de-energized and 0 if it is energized. And of course, the selected binary inputs will be listed here. Here you see the function key configuration. If you would like to use stop and start motor functions, you can enable or disable them for remote control. If you don't want to use remote motor start or stop, or in any other relay, it will be a circuit breaker open or close, you can just disable them here. And here our general alarms are listed for assigning them a tag. So what does it mean here? If I switch to input matrix, you see here 6 general alarms available for this device, which means these are custom indications from your site, from substation or from the control panel anywhere, or from a maybe transformer who holds protection pickup. So you assign new tags here. You can call them anything, and these will be appeared on your device. You can just change the tag here. And output configuration is more or less the same as input configuration. The same logic applies here. You have the output matrix tab on top. You can switch to matrix view with all your outputs, LEDs, and all your indications are listed. And the selection logic is the same. You can just CB open, select CB open here, and assign to binary output 5. And of course, all the indications, trip and pickup information can be assigned to LEDs individually. And when it comes to output configuration, of course, you can change the operation time depending on your requirements. You can assign latched outputs here, and you can choose which outputs will be pickup outputs, or if you need to use in rare applications, you can assign pulsed outputs here, which will be pulsed through. And LED configuration is here. Now we have 3 colored LEDs available in Reyrolle devices, and you can choose each individual LED as different colors here. If you choose green LEDs here, this will be appear. You can just choose which LEDs you would like to be green here. If you would like to have an LED as green, as red, you will choose here. If you would like to have yellow, or someone calls them orange, if you would like to have yellow LED, you will just need to select twice. So red plus green means yellow. So in this case, LED 1 and LED 9 will be yellow. Now this is the pickup configuration. So you can choose which protection function will trigger pickup. So depending on your binary output configuration here, pickup outputs, if you assign here pickup outputs, and if you choose protection functions here as pickup, any protection function listed here will trigger the binary outputs that were selected as pickup outputs. So this makes the life easier instead of choosing each one of them from here one by one. Under maintenance folder, we have a counter here. If this wasn't a motor protection, if this was another feeder protection relay, then we would have circuit breaker close and open counter here as well. And we would have the circuit breaker wear measurement as well. Now the data storage, you can configure the timings of your logs, like waveform storage here, and fault storage. In waveform storage, you can see the selection here up to 15 seconds with one record or with the other combinations. And you can choose the protection functions which you would like to trigger to save waveform record. And here are the communications tab. You can choose which serial communication protocol you would like to use with the relay as IEC103, Modbus R2, and the MP3, or you can simply disable it. And these are the necessary parameters to use with the serial communication protocol. Now, it is also possible to pull the data from the device itself. We have this window open. We can directly send it, but I also would like to show you to connect an existing device which you have on site. So, first of all, you click on connect. Now I have my device on my desk. It is energized and it is connected via USB port. When you click on connection manager, it opens up the available COM ports. And here in this case, it is COM2 Siemens Protection Devices Relay. And if I click on connect, now it is connected and you can see all the icons here are now enabled. I can directly get the data that I'm connected to the right now, or I can send what I have already configured here directly to device as all settings or the changed settings. So if I know that I have already changed a few settings and I would like to send them, I can just click on update change settings button here. So it will only send the change settings without waiting for the entire setting configuration file. I can also pull all the data like events, waveform records. And I can also trigger waveform record here and get data for fault records. This is the brief system information from the device which I'm connected to right now. And I can also close output relay, which have already been configured previously on the device. So let's pull the data from the device I'm connected to right now. I just clicked on it. It starts reading the settings. So we are waiting. And it asks about which setting group I would like to pull. So it seems that there are already two setting groups available in this device, which can be switchable through binary inputs or communication remotely. Now I would like to pull the data for setting group 1. If I click on it, it starts to pull the data, and here you see the information from the existing device, which is available on my desk right now. If I click on system, now you see the circuit identifier desk, and the relay name is 7sub1053. with the real information from the device itself. Now, if I would like to change any setting here, I just come over, let's change phase over current threshold to something else. I would like to increase it to 1.3 times nominal current. I save it. Okay, it's the example here on my desk. I just choose a new name and save it. Now it is saved, and I would like to send the chains to the relay. Now, if I click on it, it asks for confirmation. I click on yes, and settings are updated momentarily. If I would like to send the entire settings, now you see the update change settings is disabled because there is no change at all, and the device is already connected. Now, if I would like to send all settings, just in case of I would like to be sure, actually you don't need to be sure because it's already updated, but I would like to send all the settings now. Now it asks which setting group I would like to send to the relay. I choose one. It asks for confirmation. Again, all settings are updated. It is that easy. Now, if I would like to get the event log, I just click on get events. It's reading the events in the relay available now, but I'm not sure if there are enough events to show you, but anyway, okay. You see here the events. So this is simply all you can do with Redis Evolution. It's straightforward. Of course, I can say the content here. Now it is all you can do with Redis Evolution because it is straightforward for individual relay configuration. Now let's see an example from Redis Manager 2 for a Reyrolle 5 device. When you open Redis Manager 2, it will welcome you with the splash screen. You can create a new project, you can open an existing project, or you can export your project as a zip archive. And all the recent projects that you have already worked on are available here. There is also instrument monitor to connect to a relay real time if you have IC61850 available, so you can monitor all the measurements and binary input output status as well. Now we will create a new project. I'm just assigning a name. Let's say example 1. In this case, I won't choose any other custom location in my computer. I will just directly create it. And here it is. It is all empty. Now we need to create our first device. Now this time, Redis Manager handles as a project, not an individual relay, because here we have advanced configuration settings and IC61850 configuration. So therefore, all the relays are handled as a project. So here it is project name here. I can directly right click, create a folder structure depending on my requirements. If I have 33 kilovolts and 6.6 kilovolts substations available inside the same project, I can create a folder structure here. I can rename it SS1 substation 1, and I can add, or I will be able to add directly new 7SR5 device here as well, or I can create the devices here under the folder. Of course, I can import previously prepared 7SR5 device here, but we are now creating a new 7SR5 device. Or instead of choosing this, of course, I have ability to choose from the file menu. Now let's go on. It gives me options to choose MLFB depending on my application, or I can load a template file directly, or I can import the settings of an already connected device right now. Now I will choose from template. Now I have 7SR5421, which is transformer protection. And 5421 is two-winding transformer protection. So the selections are now being filtered. I have VT, 4 VTs with this version, and Ethernet communication is electrical. Or if first I will show you this way. 6AA, sorry, it is optical. 6AA26 0AA0. Now you can go with next. It will collect the necessary information. First, it will ask you about the firmware you need. Of course, by default, if you are creating a new device from scratch, you will want to use the latest firmware available in your computer. Of course, I'm choosing now 2.40. But of course, if you need a previous version for an existing device on your substation, you can choose a previous version as well. Now I'm clicking on next. It asks me about a new device name. I am calling it desk, and I'm leaving the MLF pin number here. And directly it is asking for an IEC61850 ID name, and I need to choose the edition. Of course, again, if we are creating from scratch, it will be edition 2, but depending on your substation, you may need to choose edition 1. And here the ID name, and I'm saying it template. Let's see if it allows. Yes, it allowed. Now it's creating the device from all the available firmware and template information. It's composing the necessary device file for us right now, and with all default settings and HMI screens. Now it's coming. Of course, preparing of IEC61850 file structure requires some time, because depending on the relay and all the settings, indications, signals, anything, IEC61850 SCD file changes. So this requires some time to set up the necessary customized relay file. After it builds IEC61850, it's completed and ready to use. Now we can see our relay, and whenever I choose it, I see all the functions here. Just a moment, I just would like to switch my USB to my 7SR5 device at this point. Okay, while it's coming, let's go over with this menu. Now we have function configuration window here. Now, as we have IC61850 configuration, everything depends on your settings, protections, indications. Any settings changed means your IC61850 file changed. So we need to go in a proper order. So I'm just starting with function configuration right now, because we will choose the necessary protection functions and it will change all the templates down under the details. This is the window you choose the necessary protection functions for your application. Now, as all other Reyrolle relays, all protection functions are always available inside the relay. These are the default values, and you can add or remove necessary and unnecessary functions like synchro check here. And as I choose here, it shows here the processor usage as well. And you can here choose the VT site, because this is a transformer protection relay. We need to choose which side the voltage transformer is in. So in this case, we are choosing winding 2, which means it is in side 2 of transformer. We can enable or disable any necessary and unnecessary protection functions here. So I'm choosing apply here, and before choosing, you can see, as this is a transformer protection relay, we have sides, and if we need to change the sides here, we can easily configure depending on our protection application. Now I clicked on apply. Now it is rebuilding the new protection functions for IC61850 configuration, and it is being written on the background if I would like to. So in the meantime, it shows here, but I can go on with my settings. After this point, it will be user settings and others. But before that, I would like to introduce the general functions here. Now, if I would like to see the properties of the relay, which I'm currently working on, I can click on properties, and it gives the device name. As it asked at the first stage when I created the file, now I can change if I change my mind, and I can change the ID name here as well and the edition number as well. It shows the IP address information here, but it is not configured here. It will be configured in IC61850 configurator, which Ciprotec and Reyrolle devices use in common. Now this is Ethernet interface. If I open it, it will show me to change the Ethernet interface options. I can here change the IP address and the necessary other parameters here. I can also enable SNMP, which means Simple Network Management Protocol. And as an additional protocol, I can use Modbus TCP or DMP3 TCP alongside together with IC61850 protocol. So this means if I choose DMP3 TCP, if you have a local SCADA with DMP3 TCP, the relay will connect through DMP3 TCP to the local SCADA, and let's assume you have a regional control center on remote and it is connected via IC61850. So this means all the indications, trip information, and whatever it is mapped to Ethernet interface will be available both via the MP3 TCP and IEC61850 protocol at the same time. Now here you can configure the communication redundancy, if it is line or switch. Of course, if you are using IEC61850, it is quite likely to use a communication redundancy topology. And if you switch to switch mode, then you will have your ring, PRP, HSR, and other configurable redundancy types. Of course, if you choose PRP, it is fixed, or if you choose HSR, it is fixed depending on standard HSR or PRP redundancy standard. Now you have the option to choose time synchronization here. We have IEEE 1588 or SNTP time server. If I choose IEEE, you see you can now use IEEE 1588 time synchronization, or you can choose SNTP with only one or with redundant time server, and you are supposed to enter the IP address information here. We also have system log for security, which is a requirement for cybersecurity. So all syslog server information enters here as IP address and port number, and therefore, if you have a remote security server which is supposed to pull the data from the relay, this is the information you need to enter for IP address and port number. Now, this is the time zone selection window here. It's quite straightforward. You can choose the time zone. You can enable or disable summertime switchover, and you can enter the time, date, actually time and date here for the summertime switchover. Of course, these are the sending device configuration and getting device data buttons. But here, the different one is set device date and time. Now, I can directly send the local PC time, or I can set any manual time and date to the device that I'm connected right now before waiting for the time server on site. So the relay will be available with a time. I can also get the time from the relay to see what time it has been configured previously. Let's assume that I have configured everything. Then in that case, I need to compile IEC61850 configuration file. You see here the status is as IEC61850 compile required. If I click on this double time, now it compiles all the information into IEC61850 language and generating the SCD file, which is necessary to import in IEC61850 configurator to create your substation. In the end, it will create this SCD file, and I can export the device as SCD file or CID file actually. I can create the substation file here individually, or I can export the relay CID file to send to whoever is preparing the substation SCD file. Now I need to wait for a few moments. Let's see here. All right, everything is okay. I just would like to click on send to background, but in the meantime, it can block me to make any further changes while it works. Okay, so let's not wait for that. And I would like to show you to get the data. No, first I need to use the user settings file, but I think it will show up, yes. Before I make any change, it is now compiling IC61850 configuration file. But if I don't change anything, I can just view it. It works on the background while I'm viewing the files. But if I would like to change anything, it will be blocked by the SCD file process. But we can view all the configurations now. Now we have two types here as configuration and functions. Configuration means the general data and actually the physical data. Functions here means protection, control, and supervision functions. Let's start with configuration. Now the device itself. Now you see a familiar screen with Reyrolle evolution with some other customized settings for 7SR5, Reyrolle 5 relays, which is more or less the same. But now we have three sets of passwords here. The extra one is for security lock. So if you would like to pull the security lock from the relay, you need to first enter a password here as a cybersecurity rule, or else you won't be able to pull any security lock from the device. Now you set the security password here, apply it, and it is set, and it doesn't show what it is. You need to keep in mind because it's security lock, and you will use this security password while you pull the security lock from the device. Now, as we have a transformer protection device here, of course, we will see side 1 and side 2 relays alongside VT voltage transformer settings here. And of course, the earth windings and earth cores are set individually. Now, this is a transformer protection device. You see the transformer data, which we need to enter to use in protection function calculations. And now regarding the binary input and output mapping, you will see a familiar screen, which is quite straightforward. Now I need to show all to see everything. Okay. Now we have directly input and indication matrix here. Yes, it seems a little bit crowded here, but to make it easier to map to a correct binary input, not to be confused, we have a double select and choose option here. Now, if I would like to assign inhibit 50 stage 1, let's say binary input 2, I choose here the box, and it shows the binary input and the selected indication in the same time, but it is not selected yet. If I select, now it is selected. Or I can use the list view, which is again in the same logic as Reyrolle evolution. Now I have already chosen binary input 2 for inhibit of instantaneous overcurrent protection stage 1. Now I can change it from here as well to binary input 3, and I will see it in matrix view as binary input 3. The interface automatically switches to filtered mode. So I need to choose show all to see all the other available binary inputs, but it will switch to mapped option so that I can see what is currently selected right now. With 7star5 relays, you can individually select the threshold voltage of each binary input individually. So if you would like to change binary input 1 for another threshold, you can choose it here. You can keep the other same. So this binary input 1 will work with 110 volt DC, and the other actually AC and DC, and the other binary inputs will work with in between 24 to 60 volt AC DC. And I can change drop-off and pick-up delays as well. Just like Radius Evolution, I have inverted inputs option here to change the 0 and 1 energization consideration. Of course, at the end of this list, you see you can choose individually all the binary inputs to make them available or not, depending on your control authority. If you would like to disable binary input 10 for remote working, you will just disable it for untick from here. So it was previously all, so it simply said all, but now I choose a customized version. It lists all binary inputs here individually. If I choose again 10, now it is all again. The remaining part is more or less the same as Radius Evolution. So the logic is the same, and it is the same for output metrics. So I don't want to make a slip anymore. Again, the same logic here. And you can also configure each binary output operation time here as well. And you can choose the pickup outputs and latched outputs here. Just like Radius Evolution, again, you can choose the color here for red and green LEDs. If you choose both, then the selected LED will be in yellow color. So in this case, LED 2 will be yellow colored. Again, you can configure which pickup of which protection function can trigger pickup outputs, which were chosen in binary output configuration here. And it is the same for trip configuration as well. Now we have the same log timing configurations here, just like previously in Radius Evolution. Here, the logic is that if I choose 10-second waveform record option, and if I choose, let's say, 20% pre-trigger storage, this means 2 seconds of the waveform record will be from before the fold, and 8 seconds of the waveform record is from after fold. So this is the logic here to choose the timing. And of course, I can change the configuration to trigger waveform record storage. Here, the communications means only serial protocol, because the IEC61850 is configured elsewhere, not from this screen. This is only for serial protocol. Now I can choose again IEC103, Modbus R2, and the MP3 to use with serial communication protocol, which is RS485. And here are the functions. Again, I can, just like Radius Evolution, enable and disable all the protection functions here, depending on the setting group you have. And when I come to protection function 3, it will show up. Now, whatever is disabled over there is disabled over here as well. If I choose, so let's see function config here, which one is enabled. Now we have 50 over current enabled here. It is disabled for stage only here. I need to enable for the stage as well. If I would like to use also the second stage, I need to enable it as well individually here. And the rest is the standard protocol for protection settings. This is how you use protection settings part. And for supervision part, now, of course, this is a Reyrolle 5 relay. We have circuit breaker protection, 50 BF. We have CT and VT supervision. We have trip coil and closed coil supervision. We have we have harmonic inrush restraint here, and we have VT balance supervision here. And for the control part, I previously enabled synchrocheck function, and now it appears here. And here is the synchrocheck function settings. And this is the circuit breaker selection part. For as this is a transformer protection relay, we will have 2 circuit breakers. And to control the circuit breaker, I am supposed to enter all the circuit breaker parameters here. And we also have circuit breaker counters. And we can monitor circuit breaker contact wear monitoring option here. If I enable here, depending on the current, the calculation will be performed by the relay, and from the event logs, we can see a brief wear information of the circuit breaker. Now it asks me to save while I'm exiting. Here is serial communications settings. Apart from IC61850, now we have quite detailed communication, serial communication settings screen here, but I'm still waiting for it to be opened. All right, it's opened in the other screen right here. Now, on the right-hand side, you can see the tabs for each serial communication protocol, which this relay is able to serve for DMP3, IC103, and Modbus RTU. All the indications, binary input, output, information, anything is already mapped and selected for the serial communication interface. I can change all the necessary communication parameters here. And the device is able to serve for each serial communication protocol. It's all available here at the same time, all mapped. So if I would like to change my serial communication protocol type later, all the mappings are available, so you don't need to configure them again. Now the user logic part, which we call it Reylogic Express. Came to an second screen now. Now, here I create a new diagram. I can get any gate from here, which is quite small. So I will just zoom in, right? And I have here the signals from all the features from this device. Let's say I can get the pickup, connect easily. And let's say, I know this is not a real-time application right now. I just chose random two signals, and I can assign them to any output I would like. Not this one, sorry. And here it is. The logic is ready. And I need to save it. Now it is saved. Now we close it down. At the time of uploading, it will check for inconsistencies. But this time, it is only an AND gate. So there won't be any consistency error right now. Now I can assign favorite meters here. As the relay has many variables, and the electrical power system has many details, normally you need to navigate through all these meters on the relay fascia. But if I choose the most necessary, the most required ones, the most frequently checked ones here, I can assign them directly to the relay screen. So I can access them with just one button while on site in real live substation. So let's choose primary current here. I can choose 15 farad meters here. And maybe I'm just interested in the direction as well. So if I have a fault or any other fault, which is not directional overcurrent protection, maybe I would like to change the direction anyway. It is possible for any other thing, or I just would like to see the binary input status as well to see while on site easily. So now these are all assigned as favorite meters. When I upload this, the relay will be available for viewing all those favorite meters with one button. Now we have the last setting here, HMI screen. I can assign 5 different display screens as mimic diagram and other reports I would like to see on the relay. By default, you see the current values here. This is not the same thing as favorite meter. This is the drawn standard screen on the device. With favorite meters, I need to choose it from the favorite meter menu on the relay fascia. So these are all separated and easy to access. Now I have all the measurements here to assign. Of course, I can't show it right now because this will take a lot of time, but you can draw your single line diagram by using all the symbols here. And let's assume we have assigned a circuit breaker. In this case, it will show up here and we can use it to control. So we can use the buttons on the relay to control the circuit breaker. But before that, I need to choose the necessary binary input, output, or any other necessary signal that I would like to trigger open or closing. So this is available here, and we can just assign any control function here as well. I want to save it right now. So let's get device information, because I'm right now connected to a device, but before that, I know that the version on this computer right now and the version on the relay available on my desk are different from each other. So whenever I would like to connect, it will ask about some differences. And in the end, I will need to choose to merge them, but instead I will show you a simpler way. Now, when I would like to get the device info, this is right now the connected device right at the moment to my computer via USB connection. If I need to get the device data, or get which is the fault records, event records, and all the others, I need to use get device data button. If I would like to settings available on the device, I need to choose get device configuration, and this will import everything. Now let's get the device configuration. I'm choosing connect by USB, but if I had IC61850 set up here, I will choose IP address. Now, I told you before, these are two different files because I created a new file from scratch, and there is already an existing setting from the relay. So these are not matching each other right now. So I have two options. I can compare and match them. I can back up the existing device and send my completely new project. Sorry for this long waiting time, but this is the way how it happens, as it is all related to IC61850. In a short while, we will see the compare and contrast window. Now, this is the settings on the device. Now I have two options here. I can import project settings to the relay, or I can update the project depending on the relay. Both is possible. And if I change here anything, without touching the project, I can directly send the new setting to the device individually. So this is my first option, but I would like to work on a completely new device. Now I choose to exit, and it asks me about to save the differences to project, show the differences if I did any, or discard completely what I did. Now I am discarding what I did. Now let's see the real action. Let's assume we will upload this later, but I don't want to lose the existing files from my relay. So I would like to create a new device from the not project, from the available device I am connected to right now. Now, this is also the way of creating a new device from a connected device. I chose import connected device. I'm choosing next, complete device configuration, next, and connection by USB. Now it is getting the entire relay configuration to the project. In this case, I'm both creating a new device and I'm both backing up the device as well. So this is the way you will need to do to work on an existing device on site. You just create a new device and use the import connected device settings, click next, and all the settings, MLFB information, everything is important directly to your project and assigned to the relay. After this point, you can change any setting, you can back up the device, and you can send all settings to the relay. I will change one setting and send back to the device, and our session will finish by my side. Now we have two relays here. The one I first created from scratch without any connection, without any relation to the existing relay on my desk. And this is the file from my existing device on my desk. Now I can change anything here. You see the last modified dates here. I can get the device data as well, all the logs and records. And here we have the event log. As this relay is an office relay, we don't have right now at least fault data because I haven't used it with an Omicron. If I click on event log, it's real time being updated. And now you see all the events available. So this is a series events happened in this time range. So last thing, let's change something and send it to the relay. I just would like to change this. CT value, close down, save it, and directly send to the relay. Now it asks about connection type. Now it is being sent. as you see the steps here, rebuild of IC618 SCL series required. So it will be required as well. So building settings 3. Now it is building IC61850 SCL3 as well, as it is required. And in the end, it will be uploaded. So as you can't see the relay with your own eyes right now, you are seeing only an information screen here. In the end, it will be written as success. So I think in the meantime, Chris Gerhardt, we can, I think, receive the questions right now, because presentation is finished from my side and the relay will be uploaded in a few moments. So we can use the time.
Thank you, Ojan. A very interesting session on Reyrolle PC tools. It must have been very thorough because we haven't had many questions, but I'll read out each question aloud and hopefully you can answer them. So, first question, remote connection through a communication network, is it possible at a later stage?
It is already available. Actually, if you have IC61850, you can directly connect from remote, and in between my windows, I showed the selection point whether to choose from USB or IP address. So here the IP address is the remote connection through IC61850. So it is already available. You can configure directly remotely from IC61850 network or from front port of the USB.
Thank you, Ojan. Second question, which I believe I can answer, is can I get the recorded video of this webinar? The recorded videos will be made available as soon as the webinar is finished, so you will be able to access that. And that is the only questions we've had. So thank you for your questions. Thank you, Ojan, for taking the time to answer them. Thank you, Ojan, for the presentation. If anybody comes up with any other questions at a later date, they'll be answered via email or just contact our specialists and they'll try to get back to you as soon as they are able. The access to the recording and slides will be sent to all participants. It has been my pleasure for me to guide you through this session on Reyrolle PC tools. I'm looking forward to meeting you soon in one of our next webinars. See you there. Take care and goodbye.
Thank you very much.